Hello everyone, welcome to this new video about custom messages in ROS2. In this project, what we will be doing is that we will create custom message instead of multiple publishers and then do our programming. So without wasting our time, let's go and do this programming step by step. At the end of the video, you will be able to execute your own codes with a custom message and you will have your own publisher and subscriber. So before going into the coding, I want to show you the project that we did previously, and we created two publishers that were Altitude Publisher, you can see over here, and then we created Velocity Publisher over here. So we had two publishers and one subscriber. So the code was well, everything was working fine. The problem with this approach is that if I want to monitor battery of the drone, so I will have one more publisher, right? So I will have another publisher file created over here, and it will become much more challenging to have more publisher with increased number of variables. So in order to solve that problem, what we do is that we use custom messages. So when we will have custom messages, so instead of having this one publisher, this second publisher, and many more publishers, actually we will have only one publisher in Python, and we will be executing our code according to that. So these commands, and they are from the previous video, and I have already built this package. But in this video, I will teach you step by step, code by code, and line by line how to create package, how to create custom files, subscriber, publisher, and how to execute them. So let's go and begin this project. So first of all, I want to clear this window and go back to the main folder. So we can see we have come to this main folder. First step is to create the packages, right? So as always, we will go to this package this folder, ROS2 workspace and src. In this folder, we will have all the packages. You can see I have already installed a lot of packages. So you may not have these packages, you may have other packages. In fact, you may not have even installed a single package when writing this code. So don't worry about that. I have used these packages, so that's why they appear here. If you have not used them and installed them, you will not have these packages. So first step is to create a package, right? So instead of using these previous packages, I will tell you how to create a new package. So it's really easy. So first of all, what we need to do is that we need to create a package, and it's very easy. ROS2 package create, right? And then we want to create drone interfaces. So actually interfaces, this package will contain our custom messages. There are other types and other extensions available in ROS2, but we will not talk about that. The main idea of writing this code is to learn how to use custom message for programming. So we will create this package drone interfaces. You may see that it is already installed over here. Okay, it's not installed over here, so that's a good news. So I will create this package over here. Now I have to define the build type. Okay, and previously we saw that we were using Python, but when we make custom messages, we will be using CMake. Okay, just remember that. For publishers and subscribers, we will use Python, but most of the other stuff that we do in ROS2, we will be using this CMake. So when we write this command, ROS2 package create, then its name, that is drone interface, build type amnet CMake, and you will press enter. So this package will be created. So we have already created this package. Now we have to create the second package, right? So ROS2 package create. Now drone, I already have these packages over here with drone name, so I just want to name it something different. So let's name it as drone project 2. Okay, just to drone project. Okay, I want to name this because I don't have this package installed already with me, so I don't want to overwrite anything. So let's name this ROS2 package create drone project. Now we have to define the build type. So this should be AMNET Python. Why? Because the subscriber and publishers, they are coded in Python, but the interfaces that includes custom messages, that is coded in CMake. So when I press enter, my another my another package is already created. I just want to see that if it is really created. So I will write ls and it will show me all the files in this folder. So we can see here we have this drone package, drone project package that is installed, and we have this drone interfaces. So we installed these two packages right now. Okay. Now the next step is we have to go to this folder of drone interfaces and create our custom message. It's really easy. Once again, we will go to that folder. So how do we go to that folder? We simply need to write cd drone interfaces. So we will be inside that folder. Let's see what do we have in this folder. So I will write ls. So it will show me all the files I have. We have CMake lists and package.xml. These files are important for us. Now, I want to create a custom message. So it is much better that I create a message folder for that. So I will create a directory, make dir. So make directory, this is just an abbreviation for that, and it is used in ROS2 for creating a folder. So we will write make directory message. So it will create message folder in this drone interfaces package. So once again, we want to see if it is created. So you can clearly see it over here. Message folder is created. Now I will access this folder. And how do we do that? cd message. So once again, I want to see what is inside this folder. So it is empty. There is nothing in there. So why did I create this folder is for my custom message, right? So how to create a custom message? We know this, that nano, when this command is written in ROS2, it creates the file. So we must write its extension name also. So what I need is that I will write nano drone telemetry. Okay, I name it drone telemetry because drone has many states and they can be summarized with this one term. So we will create this file. But now the important point is that we have to write the extension name over here. Okay, and what is our extension name? That is msg, because we want to create our custom message. So remember that whenever you use nano command, you must write the extension with it. You will see later on when we will be creating publisher in Python. So when I write nano command, at the end I will be writing .py, which represents Python file. So when I write this command and press enter, it will open that file DroneTelemetry.msg. Okay. Now the coding in this file is actually very easy as compared to the publisher and subscriber, because we simply have to define the variables over here. So float 32, I use this. For altitude, I have to be very careful with spellings, because even a small spelling mistake leads to errors in programming. It can be C language, ROS2, or any other. So whenever you are doing programming, you have to be very careful with the spellings, even small alphabet and capital alphabet. So I defined altitude. Next variable that I want to monitor is that velocity, and the third one is battery. So you saw in the previous video we created publisher for altitude and velocity. If in the same previous project I had to create a battery, so I would have needed one more publisher. So it would have been a lot of tedious tasks and a lot of repeated coding again to create one more publisher. But instead of doing that, this is the advantage of custom message. We can create just one file and define all the states in it. So if later on we are talking about roll angle, pitch angle, or any other parameter, for example, we want to see the time, the flight time of the drone, so we can also add that over here. So with this, actually what will happen is that we will be only programming one publisher instead of a lot of publishers. So we define altitude, velocity, and battery. Okay, so once you write this, then you have to press Control O, then enter, and then Control X to close it. Just if you want to see if it is really created, so you can write Control Cat Drone Telemetry message. We got some error over here, so I need to see that. But let's see if it's published over here. So error in home, this nano RC on line 1 unknown table size. We will see that later on, but it should not be over here. So let me debug it. Okay, so I debugged this code, and actually this is not something to worry about. This stems from my previous projects that I did in this ROS2. And previously, just to give you the answer for it, previously there was a mistake in my code and I was not using tabs and spacing in my code appropriately. So I used some code for that to fix it automatically. So actually there was one alphabet mistake in that, in exactly this file, that .nano rc. So I fixed that. So you will not have this code. In fact, you will not have this error when you will be creating this nano file. So don't worry about that. If you have, simply access this file, and then you will be able to fix it. And there will be this one mistake. So okay, let me show you. I think I should show it to you because it will be useful for you if in case you have this mistake. So you will open another tab. Okay, so you can directly write nano / nano rc. It was already written there, and the mistake was that in this line tab size 4, it was actually written tabl size. So that was a mistake. So previously it did not give me an error, and now it pointed out that you have a mistake here, so be careful about it. So you can see it over here as well. It pointed out exactly the same file over here. So don't worry, you will not have this error. Okay, back to the project. We saw that we have created a DroneTelemetry.msg file. Now, next is that we have to add this file and configure some interface packages. So how do we do that? So what we need to do is that we need to go one folder back. I think this is the command, and we will see that we have these files cmakelist.txt and package.xml. I told you these two files are very important for us. So we have to add some lines to this code. So how do we do that? Once again, we will be opening this package.xml file, package.xml file, and you will see there is a lot of coding already present there. So don't worry about that. We simply have to add these two commands in this folder, and that is actually very straightforward. You can come over here. Let's add some spacing. So what we need to do is that we need to add this depend ROS IDL default generators. Okay, then /depend, and the next one is depend, once again ROS IDL default runtime, and then close it with depend again. Okay, so we have to add this over here, and then next is to add one more command over here, member of group ROS IDL interface packages, and then close this with the same. Be careful about spelling mistakes. Okay, I'm trying to type it slowly to avoid any mistakes that we may make. So we just have to add these three commands over here. After that, Control plus O, then enter, and then Control plus X. So we have modified our package file. After that, what we have to do is that we have to modify the CMake list.txt. So how do we modify that? We already saw that. We simply have to write nano and open that file. By the way, this nano code, it can open and edit the file that is already in the folder. If it does not exist, then it creates that file. We saw that when we were creating DroneTelemetry.msg. So CMake lists.txt. So it will open this file again, and we will see a lot of code is already written over there. So now what we need to do is that we need to add our few commands. So we will be adding it over here. Let's add it over here in this find package. You can see they have already added these comments. They are telling you to add the files over here. So I will not touch that, and I will directly add my package over here. If you recall, we use this ROS ideal default generator in the package.xml file. So I will call it over here. So ROS ideal default generators, and this is required. Okay. And after that, what we need to do is that ROS IDL generate interfaces. Okay. Then we will call the project name project underscore name, and then simply we have to add the custom message that we created. So message in that folder, there is a DroneTelemetry.msg. We are telling this file to read that, and then we will close it. So okay, I made one mistake. This bracket will be over here. Okay, what happens is that in this same bracket, project name, and then we call that message file. After this, we need to add dependency. So mnet export dependencies DEPENDENCIES, and then ROS IDL. If you recall, we also added this in the package XML. Okay, so that's it. After adding these commands, what we have to do is that we have to save it. So Control O, enter, and Control X. Okay, so we have modified package file, we have modified CMake lists. Once again, what we did is that we created a custom message named DroneTelemetry.msg. After that, we modified the package file and CMake lists file. The code that we used in package.xml file, we called it in CMake list.txt. Okay, so once this is done, after that, we have to build interface for this custom message on the package we created for this custom package. So we need to go back to the main folder, and if you have been watching my videos, you already know this, that why we do this. So colon build packages select. Okay, you can directly write colon build, but why I'm selecting the package is that you can see I already have like 6 to 8 packages. So when I write only colon build, it will build interface for all of the package. So I do not want to waste my time. So I will directly call the package that we created. So colon build packages select, and you can see over here we created this drone interfaces package for custom message. So I will call that. So I will simply write drone interfaces. If everything is done correctly, this will build the interface. So we made some mistake, and the mistake is in CMake lists. So let's find out and fix that mistake firstly. This is good because when we build this interface, so we can, even before doing any more programming, we can find out if we have made any mistake. So I think there is some spelling mistake. Let's see uh, how to fix that. So we need to open the CMake list.txt because it is already telling us that you have a mistake over here, CMake, and we may have a mistake in package XML as well. So let's see and fix that first. So we already know the mistake in this file, that it might be in CMake lists packages.xml. So we'll open the files. We can directly go to that folder, src drone interfaces. We need to see, yes, we are in this file, in this folder. So let's open these files. So we added these two lines over here, and we also added these two lines over here. So depend ROS IDL. Okay, this is the first mistake that I already saw, and I already told you that we have to be very careful with the spellings and don't rush everything. So this was the first mistake, and then default generators, ROS IDL default runtime. So this is the second mistake. Now the third mistake, I went online and found out what mistake did we make. Third mistake is in this line. This member of group should be outside this export window. You see this export window over here, so it should be outside that. So what we need to do is that we need to write it over here. See, what did I press here? So what we need to do is that we need to write this outside over here. So instead of deleting it, let me write it over here. Member of group ROS IDL interface packages, then close it with member of group. Okay, so I will simply, instead of deleting it, I will add it as a comment. Maybe we will need it later on, but it's not adding it as a comment. Yes, that command is for Python. So okay, I will delete it like this, and we can see the file has been modified. After that, Control O, enter, Control X. Now let's see if we can build our workspace. Colquon build packages, select drone interfaces. So we will see if there is a mistake, it will give us a mistake again, but fortunately no more mistakes. So next is install the setup.bash. Install setup.bash. I think I made a mistake over here. Install setup.bash, and it's done. Okay, so this is the first part of the custom messages. And second part, actually it is much more easy, and I'm sure you already know about that, because if you have followed my videos on this channel, I already told you how to create publishers and subscribers, and we will be doing that, but I'm just giving you a review of what we have done so far. So first of all, what we did is that we opened this folder src and saw which packages do we have. You may have no packages over here, but if you have a lot of packages, so no problem, it will be different for everyone depending upon the use of a ROS tool. I had these packages, so what I did is that first of all I created two different packages. One was for interface. That interface package actually contains the custom message, and one is for my publisher and subscriber. So the name of that was drone project. You can see it over here. So first step, create two packages, one for interface, one for your own project. Now the key point is, when creating the package for interface, you should use AMN AMENT CMake. Okay, remember this. But when creating a project package, you have to use Python because we will be creating publishers and subscribers in Python. Once both packages were created, after that, what I did is that I accessed this first package of interface and opened it. So we saw we had some files over there. CMake list include packages.xml and src over here. We saw this. Then I created a message folder where I can put my custom message. So I wrote make directory and this message command. It created a folder with message. We saw it over here. When the message folder was created, inside that folder, we created the DroneTelemetry.msg, this file, which is actually a custom message file in ROS 2. Once it was done, after that, what we did is that we built the interface. So we have this command for that, kulkun build packages select drone interfaces, because we created custom message inside this drone interfaces package, right? So we have to write this command. If we write kulkun build, that is also okay. If you have no packages installed, it will only process that one package. But if you have a lot of packages installed, then ROS will be compiling and building interface for all of them. So it is more time consuming. So instead of that, what you can do is that you can also add this prompt packages, or this command packages select, and directly target the package that we want to build. So it built the package for us. There was a small error in this, and the error was due to two reasons. One reason was that I did some typing mistake, and the second reason was that I mistakenly added one command inside export, but it should be outside that export in the package setup. Once we fixed that mistake, after that we also had modified CMake lists along with these files. Once everything was done, we built this package again, and then we installed the setup once again. So the path of interface package is done. Now next step is to create our publisher and subscriber. Now in the second part, what we will do is that we will be creating our publishers and subscriber. So we will directly go to the second package that we created. By the way, if you create only one package of interface and do all this stuff of CMake lists, package.xml, and create your custom message, and then at this point you want to create your second package, that is also okay. So don't get confused in that. If you see in other videos or other courses that they create interface package first, then do all the stuff in that, and then create their own package for publisher and subscriber. So don't confuse in that. The idea is same. You need two packages, one for your publisher and subscriber, another for your interfaces. So far what we did, this all the programming and coding, it was in the interface folder. Now we will go to the main folder where is the project located. So cd src, and then this was our package, right? So I will write ls, and it will show me all these files over here. So this is the drone project package, and the Python module that we will be used for creating publishers and subscribers, it will be inside this drone project. Okay, so recall that previously we created message folder because it did not exist, but for this Python package it already exists over here. So we will open this folder, cd drone project. So you will see there is only one initialized Python file, and we will create our publisher and subscriber in this folder. Before creating publisher and subscriber, I suggest you that at this point, usually you can do this at the end after creating publisher or subscriber, but my suggestion will be to do it at this point. And what you have to do is that you have to do some modification in this package.xml. remember that this package.xml file is inside the project folder, not in the interface folder. So we will go to this folder and we see we have these files. I want to open this package.xml, and I only have to add one command over here, and the command is that I have to connect this package with the interface package. Okay, and the command is actually very simple. That is, let's add it over here, not inside the export, this export commands. So the command is actually very easy. Depend, okay, drone interfaces. We created this package for custom message, right? So we just have to call this over here in this package file. That's it. Control O, enter, Control X. So the package file has been modified. Now I will go to the Python module, and we will see we will create our files over here. By the way, one more key point, so you don't get confused when reading books or watching videos or learning from any other sources. You may see this, that when we open this folder, cd ROS2 workspace src drone project, this is the package that we created, and you will see this name again, drone project. Okay, so the reason for this drone project written twice is that the first one represents the package, the second one represents the Python module where we create our publisher and subscriber. So you will see when I press enter, it will take me to this folder. So we are inside this folder. Okay, so previously I did it step by step, so you may not have noticed that actually this command and this word actually is written twice. So don't get confused with that. The first drone project, this represents package. The second drone project, this represents a folder or Python module inside that package. Now everything is ready. Now the next step is to create our publisher. Creating publisher is very easy. We already learned that there is a structure for that. I will be teaching you that once again. So we will write nano, right? And we will create our publisher. So let's name it as drone project, okay, and then publisher. Why did I write drone project? Because the package we created is drone project. Okay, if you create the package name differently, for example, you want to create like drone simulator or drone telemetry, so I suggest you to use the first two words as it is, so you don't get confused later on when you will have a lot of files. I can name this as a drone publisher directly. I can name it anything, okay, but just to remember it more easily, I suggest you to use the same words as the package and then at the end write publisher. Okay, you will not find this suggestion anywhere. This is what I learned during my learning experience, because previously when I was creating these files, I was naming them differently, and then I used to get confused and had to go back all the way in the screen and see the names. But I realized that I can name them same as the package name and then add publisher at the end. Similarly, when I will be creating subscriber, package name underscore subscriber. Now, how to create publisher, nano, drone project, publish, and then extension. This is very important for us. Okay, so you must add this extension. So it will create this file for us. Okay, so the file has been created over here. Once again, if you have seen previous videos, I have already explained this coding in a lot of detail. This coding is not difficult in the publisher. There is just a structure for it, and there are 4 steps. First one is to import files. Second one is to define an initialization, make a class for the node, and so on. There are just 4 steps. If you can memorize or understand the structure, then this programming becomes very easy. I would say it becomes like a piece of cake. When I saw this code for the first time, I was really confused and I was kind of scared that it's very difficult to code this. But when I understood the structure, it became very easy. And once again, I will do this programming step by step so you can understand the structure. So the first part of structure is to import the libraries. Okay, so import RCLPY. This is used everywhere. Okay, so import RCLPY. Next is from this we need to import node. Okay, one more key point, this N in node should be capital. Okay, be careful about this. Next, if you saw the first or second video I uploaded, so it was like from std messages dot message import string, or if we are dealing with float, we will import float 32 over here, or float 64, anything we want we can import here. But now the point is we created our own custom message, right? We created that custom message, so I will be calling that. Okay, so I want to show you this. Let's save this, Control O, enter Control X. So we created our own custom message over here, and its name was DroneTelemetry.msg. So instead of using the built-in message file, I will be calling the custom message that I created. Okay, so it's very easy. I will go and open this publisher file again. I simply pressed the arrow upwards and it showed me the last command that I wrote directly. So instead of typing, I can press upwards arrow and it will open the file. So we have to be very careful about these mistakes. From DroneTelemetry.msg import. Okay, so we have to import the file from here. So now the mistake I made over here, actually it's not a mistake, it's a conceptual point. DroneTelemetry.msg, it is present inside a package. Okay, so first of all I have to call and tell it that from that package extract that custom message. So the name of the package was actually drone interfaces, and then there was this message, so dot message import drone telemetry. Okay, so this is the first part of this code. So I told you there are 4 parts, and these 4 parts are like a structure of this code. So first part is already done. Very simple, right? Now second part, what we need to do is that we need to define the publisher. So drone, let's name it like this, telemetry publisher. Okay, and it should be a node. Don't forget to add these double dots at the end. Now in this second part of the structure, I told you 4 structures, so we are in the second part. It's very easy. Define initialized self. Okay, and then we have to define a timer callback. You will see why do we do that. Okay, that's it. This is the second part of the structure. We will simply be filling out each part of the structure, and then we have to define main args equal to none. So this is the third part. We will be adding few commands over here, and the last one, it is same everywhere. So far whatever I have done, this last part is actually same as this in all the codes. So this is the structure of the code. Now we will be filling each structure. First one is already done, so let's go to the second part. So we have initialized it and called it to itself. So the next part is, in this, what we need to do is that we firstly need to super initialize, and I will name it. So this will be the name of the node. Okay, so let's call it as drone telemetry publisher. This will be visible to us when I list the nodes of this project. Now next one is very easy. We have to create the publisher. Self publisher is equal to, once again, self dot create publisher. Very easy, right? publisher, and we will write this brackets at the end. Next is we will create self.timer, right? We have to have this time for the simulations. So create timer, and that's it. So this is the second part of the structure which we are filling out. Now, when we create the publisher, it must have some data inside it. So what is that? We will write it over here. It should call the custom message, DroneTelemetry. I'm trying to be careful about spelling mistakes. And then we need to name the topic. Okay, so drone telemetry. Now remember that the topic name in publisher and subscriber should be same. So you should be very careful about this. Okay, so drone telemetry, I named this topic, and then the next one is that I want to store the data up to 10 numbers. When we fly the drone, its height changes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I'm in another window, it should at least save the data of the past 10 simulations. That's it. Now, next part is self.timer. Similarly, we will be filling this timer, but timer does not depend on drone telemetry, and we can directly tell it that simulate it for each second. And then the next command is this should call the callback, which is defined under this. So this should call it timer callback. I'm trying to be careful about spellings. If you point out a spelling mistake, you should do it correctly. But at the end, we will see when I simulate this, if there is an error, I will have to fix it. So that's it for timer. For timer, we don't need to define drone telemetry. We can directly tell it 1.0, and after each 1.0 second, it will simulate. And in timer, we call this timer underscore callback. Okay, so this is the important part of the code. Now, what we need to add is that we need to initialize the drone velocity, altitude, and battery. When a drone is placed at the ground, it will have zero height, zero velocity, and if it is not operational, its battery will be full. So let's say it is 100%. Okay, so we need to initialize that over here. So how to do that? Self.altitude at the beginning, it should be 0.0. Similarly, self.velocity at the beginning should be 0.0. Self.battery should be 100% at the beginning, because the drone is not operational yet and battery is full. So that's it. Now we will come to the timer callback. The coding for timer callback is actually more easier than the initialization. You will say that. So first step, we need to define the message drone telemetry in the timer callback. Okay, we saw this in the import as well. Now in this message, let's go a bit down. What we need to do is that message.altitude. Okay, this should be self.altitude. So you can see we initialize this to 0. So at the beginning it will be 0.0. Similarly, message.velocity. This should be self.velocity. So at the beginning it will once again be 0. And similarly, message.battery. This should be self.battery at the beginning, right? And after that, what we need to do is that we need to publish this information, because once we have the information of the drone, we need to publish it, right? So self.publisher, we already defined this up there in the code. So this should publish. And what should it publish? It should publish the message. That's it. Then we have to log this information. So self.get logger.info. And then in this bracket, we have to write the custom message that we want to write. I'm not talking about the custom message that we created. I'm talking about the words that we want to print out. Okay. So what I need to do is that I will write this f double dot altitude of drone. You can write anything you want. You can write height of drone. This is up to you to choose. Okay. So what will be printed? Altitude of drone, and it should print message.altitude, which we defined a few lines ago. Message.altitude. And if you want to be more fancy, you can add the units. So this M represents meters, and then add this line. If you don't add these, it's your choice, no problem, don't worry about this. Then next one, F, these columns, velocity of drone. Okay, what will be the velocity of drone? It should be message.velocity. And now we know the units of velocity, it is meter per second, and that's it. Next, F double dot, battery of drone. Let me fix this. It doesn't matter, but I just want to be consistent. Battery of drone. So this will be message dot battery, right? And I will add percentage over here. I hope this percentage dot does not give me a mistake. I don't know how it works in ROS 2. So that's it. And then I will close this logger. Okay. Now what happens is that when drone starts to fly, it increases its height, right? So let's call it as self altitude plus equal to 1. So we will say the height is changing by 1 meter. Self dot velocity plus equal to, let's say, 0.5. It is changing by 0.5. And then when drone is operational, its battery will reduce, right? So instead of plus, I will write minus equal to, let's say battery is reduced by 0.1% after each second. So don't get confused in this self.altitude and the self.altitude we defined over here. This is the initial state of the drone, okay? And when this simulates for every second, then the altitude, velocity, and battery will change. Now you see I made a big blunder over here. I defined self velocity twice. This would be battery. I hope I have not made any similar mistakes. So this is about timer callback, which is the second part of the structure. Now next what we need to do is that we need to go to the third structure, right? Just wait a moment. So in the third structure, actually it's much more easy, and what we need to do is that it's already a fixed code, so you don't have to worry about this as well. So the third and fourth part of the structure is actually more or less the same. It so far it has stayed the same for me, so you can just memorize this. And what is this? We will do it now. So the first one is RCLPY initialization. Args is equal to args. So this command actually tells ROS2 that wake up, we have a code and we have to do some programming. Then we have to call the node, and you saw this, that we defined this DroneTelemetry class up there. I will show it to you. Just wait a moment. So we defined this in the second step. You can see it over here. DroneTelemetry publisher node. So we are calling that node in this command. Then next one is RCLPY spin. So it should work, like it should simulate continuously. So the spin command is used for that. And then if we want to stop the simulations, so node destroy node. And if we want to shut down code, you will see we will be using Control-C to stop the simulation. So that is, I think, done using this command. I'm not sure if it's done using this destroy node or shutdown, but one of this command is used for Control-C. And the fourth part of the structure, I already told you, it is same as this one. To give you a review, there are 4 parts of publisher coding. First one is to import the libraries. Okay. Second one is to define the class and name the node. In that class, we have to initialize and create a timer callback. Okay. Once we do the initialization, in that initialization, we have to super initialize and name the node. Okay. Once node is named, after that, we have to create the publisher. And inside the publisher, we have to call the custom message that we created. Then we have to name the topic, and this then represents the number of data or information that is stored. Next one is we have to create this timer. So for timer, it is much more simple and easy. It's 1.0 for every second, and it calls the timer that will be coded later on. After that, what we have to do is that we have to tell that the initial state of the drone is that its height is 0, its velocity is 0, and battery is full. Next, in timer callback, we have actually the main part of the code. We define the message, which is already calling the custom message, and then we have to tell this message dot altitude, because if you remember in drone telemetry we defined altitude, velocity, and battery. So we have to save this information in this message. So message dot altitude is equal to self altitude, message dot velocity is equal to self dot velocity, and so on. If you have more variables, you also have to define that and call them in the message. After that, we have to publish the message. So self.publisher.publish this message. So this message will publish this above information. And after that, we have to log this information. So for that, we have this command self.get_logger.info. And then we have to write these messages. So whatever you want to write over here, you can write altitude of drone, altitude of quadrotor, plane, whatever you want to write over here. And then in these brackets, you will have to call the message.altitude, which is defined above here. Similarly for message.velocity and battery. In the next step, inside timer callback, you have to perform this simulation. When drone flies from the ground and it takes off, so its altitude changes, right? So we say it is changing by 1 meter. Okay, so plus is equal to 1.0. So it will update to 1, 2, 3, 4, and so on. Similarly, its velocity will also change. So we say it is changed by 0.5. And for battery, when drone starts to operate and flies in the air, its battery reduces, right? So we say it is reduced by 0.1. That was the part for this second step of this structure. The fourth one is actually very straightforward. You can memorize these lines: RCL py.init args is equal to args, and so on. And the fourth, the last one, which is if name is equal to main, it should do this one. I hope there is no mistake in this code. Most likely, if I have made a mistake, the mistake will be for the spelling one, but everything else looks okay to me. Once you finish this code, what you need to do is that you need to press Ctrl O, then enter, and then Ctrl X. Okay. So our publisher is created. If you want to see that, we need to write cat drone project publisher.py. So this cat command will actually print this file. You can see it is showing us this code over here. Now the next step is to create the subscriber. Publisher sends out the data, but we also need a subscriber to read that data, okay, or listen to that data. So if you understood publisher, the subscriber is much more easy than that. So you will see drone project subscriber.py. Now, just to tell you once more, you can name it anything you want, okay, it's up to you, but I suggest you to use the package name, which was drone project, and then add subscriber to it. When I was learning, I made this mistake and I used to name it differently, and it was a trouble to find all the files once again. So I suggest to use package name, then underscore. If you are creating publisher, you can write publisher. If you are creating subscriber, you can write subscriber. And at the end, adding that extension .py is very important. Okay, so it will create this Python file. So if you saw the previous code, you will understand that there are 4 steps in the structure. First one is call libraries. From import RCLPY. From RCLPY.node import node, right? Next one is from drone interfaces.message import drone telemetry. Okay. So this is the first part. I just want to confirm if I wrote drone interface or interfaces in the publisher. So I just want to confirm that. So we will save this, Control O, enter, Control X. How do I see that? I will simply have to scroll up and we will see drone interfaces.msg. So okay, this is not a mistake. I will open the file. Now the second step is to have a class file, drone telemetry, okay, and subscriber. Remember this, okay. So drone subscriber node, drone telemetry subscriber node. What was the first step? First step was init self, right? And inside this, we need to super initialize, super init. We also have to be careful about these underscores, okay? Not one, but we have to add two. So I will see again if I made a mistake in publisher. But anyways, let's name this drone telemetry. The good news is whatever you write and it's shown in green color, that's okay. It can have different names or something. But in this coding, you have to be careful about alphabets and underscores. So we have super initialized this. Now, previously we created publisher. This time we will create a subscriber. So for that, I suggest to use this command self.subscription is equal to self.create subscription. Okay, subscription. Okay, we have this one. Now, previously we had timer callback, but subscriber, it actually listens to the information that is sent by the publisher. So instead of timer callback, we will have listener callback. Okay, we will see how do we fill these informations. Now coming back to this self.subscription, it is same as the previous one. As the publisher, we have to call drone telemetry, the custom message that we created, and then we have to use the topic name. So remember, I told you this topic name should be same in both publisher and subscriber. Okay, so drone telemetry, and then just one extra command, because this should listen to the callback. So previously we used timer callback inside a timer, but now we don't need timer, because if data is sent, subscriber will listen to it. If data is not sent, subscriber doesn't care about the simulation time. So self.listener underscore callback, and once again same as previous 10, and close this self.subscription. By the way, I just said that the terms written in green color, they should have different name. It does not give an error. By that, what I mean is that the names of nodes, okay, the names of node or the message that we write at the end. But this topic name, this should be same as the publisher name. So don't get confused in that. Okay, so now we are in the second part of the structure. We have initialized. Now we want to create listener callback. So this is very easy. Self.message. We need to add this over here and directly go to the logger instead of doing all the previous stuff, because this is the feature of subscriber. It only listens and doesn't care about other stuff. So get underscore logger dot info, and now we have to fill this. So how do we fill that? It's very easy. You will see. Just to distinguish between the previous message of publisher and the message of subscription, it will say received drone data. Let's add this arrow to it over here. So what data? F altitude. And what will be the data inside this? It will be reading the velocities and altitude and battery. So previously we defined that message altitude. Previously we already defined this in publisher, right? And it should be in meters. Let's add this here. velocity. Previously I wrote altitude of drone, velocity of drone, so I don't want to write that because I want to distinguish between this text that is shown in the subscriber. So velocity message dot velocity meter per second, and then battery message dot battery percent. This percentage actually worries me. I don't know how to use it in ROS2. So this is the second part of the subscriber that we have already programmed. Now the third part, I already told you, this stays more or less the same in all the codes. So rclpy.init arg is equal to args. Then we have to call the node, and the name of the node here is DroneTelemetry driver. Okay, this is the name of the node. And after that, what was the command? rclpy.spin. I think this was the code, right? And then we have to close the simulations. So it was node.destroy node, and then shut down rclpy. And if name is equal to this, so far this has stayed the same in all the codes that I have uploaded. So it is easy to memorize. I built few projects, so I have already memorized this third and fourth part of the structure. Most of the time, what we change is that the listener callback or the timer callback previously. Most of the programming is done over here, but it is very simple, not very difficult. So subscriber file is done. After that, what we need to do is that we need to save it. So Control O, enter, Control X. So second part is already done. We have created a publisher, we have created a subscriber. Now what we need to do is that we need to go back to the main folder and build it. So cd ROS2 workspace. Now I can do kun build, but you saw previously that I have a lot of packages installed. So instead of that, I will just select this package of drone project. So if there is no mistake, it should work. Yes, fortunately, no mistake detected. Sorry for my English. Now this. By the way, I forgot one step, and that is actually the important step over here. That is that I have to add these subscribers and publisher in its own setup. So what do I mean by that is that let's open this package that was drone project, right? So we can see we have a lot of files over here. So package.xml, I already told you that we have already added that one command over here. But at the end of the project, we also have to, at the end of creating publisher and subscriber, we have to also modify this setup.py to add this publisher and subscriber in it. So how do we do that? It is actually very straightforward. We open this file. So in this console scripts, right at the end, I have to add this publisher. So we created a publisher, drone project publisher, and then the package name. This should be equal to drone project. This is the package name dot drone project publisher. It's actually very straightforward command and main. Okay, you just have to tell it that drone, you will see drone project subscriber. Okay, after that drone project, this is the name of the package, and inside that package we have the subscriber. project subscriber main. Okay, so that's it. We have to add these two commands. So if there are no mistakes, we will see. So it's done. After that, you have to do this cd ROS2 workspace. You go to main folder. I have already added this command, so I will press this up arrow and go to this command and press enter. And I hope no mistakes. Yes. Source install setup.bash. Now there is one interesting command that I want to try. I forgot about it, but I just want to try it. Executables, ROS2 package executables, and drone project. Yeah, so the command is right. ROS2 package executables and drone project. We have been working in this, right? We created our publisher and subscriber, so it is showing to me that we have a subscriber and publisher over here. So we have already built the interface. Also, we have installed the setup. So now we can run the code. Let's see. I hope there is no mistake because we spent a lot of time coding this. So ROS run, then drone project. This is the name of the project, the package we created, right? And run the publisher. So drone project publisher. Now before pressing enter, if there is no mistake, for example typing mistake, some underscore mistake, this will work and show us the information. I hope there is no mistake, and we will see that after I press enter. So we can see that it is showing me some mistake over here. We need to debug that, and it is telling me the mistake is in publisher file. Okay, so drone telemetry, this is the name of the drone telemetry publisher, and you can see here I think the mistake is about this E. Okay, I added one extra E after T, so it is already telling me, did you mean drone telemetry publisher? So let's open this file. cd, I will write full commands instead of directly going there, so you can also take notes of it. Project. The good thing about ROS is that it tells you where is your mistake and how to fix it. So I will open this ROS2 src, then package, and inside the package there is this module name. So don't get confused with the name written twice. So we will see here we have these files over here. I will directly open it instead of printing it. So drone project publisher.py. So here I name this as a drone telemetry, so TRY. So I think the mistake is right at the bottom over here. I added one extra E. So you saw that how to fix this kind of an error. So this is more like a debugging, and you also learned that in this video. So after fixing the mistake, Control O, enter, Control X. I can directly go and build the interface again, but just to be on a safe side, I also want to see if I made this mistake in subscriber. Okay, so drone telemetry subscriber, okay, TRY, and at the end it is TRY. So I hope there is no other mistake. I just want to confirm if I use double underscores over here. Yes, single underscore at the end, double underscore. Okay, seems okay to me. Control O, enter, Control X. So instead of writing the command, I will directly press the up arrow, go to the main folder, then I will write this kun build package select drone project. I don't want to write it actually. I will just go up there and press enter. So I hope no mistake. Yes, no mistake so far. Source install setup.bash. I just want to confirm once again the executables. So it will show me the executables. And now I will run the publisher. So if everything is okay, it should run, and I really hope so. So it is giving us an error again, and now we will see the mistake. The mistake seems like we have a mistake in the setup file. I can already see this over here. Console underscore scripts drone project underscore publisher. So this looks okay to me. Okay, I realized the mistake. I realized the mistake. I think I did not add double dot main at the end. So I will go to the same folder once again. Instead of writing the full command ls, okay, we are inside the module, so we will go one folder back. So cd minus, and it will show me the file. Sorry, I made a mistake or something. Okay, we can access it like this, drone project. Okay, we have this setup file, nano setup.py. I've written this over here, drone project underscore publisher. That's the name. It looks okay to me. And then drone project subscriber, drone project subscriber, double dot main. Looks okay to me. I want to see the mistake again. So the mistake is somewhere self.spin and home drone project Python side package drone package. Mistake is inside this publisher.py and line 52. Okay, I realized mistake. So we need to go to this folder. We need to open. I will just write command because it's very confusing. Nano drone project publisher.py. So I think the mistake is down here somewhere in the spin command. So maybe I added or did not add something. Spin node, destroy node. It looks okay to me. I'm not sure why exactly it is pointing out this mistake. RCLPY shutdown spelling is okay. Node.destroy node. This is also okay. RCLPY spin node is also okay. DroneTelemetry publisher args. So everything looks okay to me. I will just debug this separately in another window. Just wait for me. Okay, I found out the mistake, and thanks to ChatGPT, it pointed out the mistake directly for me. I'm still not sure if it will work or not, but it told me that in timer callback, we have not added this self over here. So we need to add this self right over here. And where is the key? Self. This is the mistake according to ChatGPT. It says for a ROS2 timer callback, it must be def timer callback and self, because the timer belongs to your node object. So why ROS was saying one was given, so it created some timer, and there is this whole theory behind it according to ROS. According to ChatGPT. But this is the mistake. I know this because previously I have done programming and I used to add this self, but this time when I was teaching you this code, so I forgot to write self over here. So Control O, enter, Control X. Once again, we need to build the interface. So we need to go back to the main folder, cd ROS2, then select packages or packages select, which is actually the main command, and drone project. It will build the files again, and we need to go to source install setup.bash. Okay, and just to be confirmed, okay, executable, it is always showing me executables, so I will directly run the code here to see if the publisher works. So ROS2 run, then the name of package, that is drone project, and then the publisher name, that is drone project dot publisher. By the way, you can see here why I suggested you this name drone project publisher, because it is same as the project, so you will not get confused. If you remember the package name, you can easily remember this, that you have created a publisher with the same name. So drone project underscore publisher. So I will press enter again and see and hope that there is no mistake. So you can see our information is published over here. Altitude of drone is 0 meter, velocity of drone is changing, battery of drone is also, initially it was 100%, and it is also reducing. Now this is sending out the information. It's more like a talker. If you learned a ROS2, the first project that is usually taught, it is about talker and listener. So this publisher is actually talking. So we need a listener, which is actually a subscriber. So I will open another window. And if there is a mistake in subscriber, we will have a mistake pointed over here. So we will do the debugging for that. If there is no mistake, it will be working and listening to the information sent in the another window. So ROS2 run drone project. Once again, it is very easy to remember this name, and then we created subscriber. So if there is no spelling mistake, dot, or if I forgot anything, then we will see there is a mistake or not. So we see there is a mistake over here in console scripts. It gives us this error drone project. And once again, did you mean drone telemetry? So I think the mistake is in this drone telemetry. So we did some mistake over here. We need to find out that right at the end, it is already telling me cannot import drone telemetry from drone interfaces.msg. Did you mean drone telemetry? So the mistake is most likely that I have added an extra E somewhere. So we already checked that in subscriber. So we will see it again once more. So what I will do is that I will open subscriber file cd ROS2 workspace src, right? And then drone project, and then drone project again. Okay, this will have my subscriber and publisher. So nano drone project subscriber.py. Okay, so it has already told me that I have a spelling mistake somewhere. So from drone interfaces.messages import drone telemetry. Okay, here is the mistake. I want to see once again if I written it incorrectly. So drone telemetry, again it is correct. This name should be, by the way, same as the custom message file that we created. Don't forget that. Okay, so drone telemetry is fine over here, and it is not used anywhere else. So Control O, enter, Control X. I will go to the previous window. I will stop the publisher because I will be doing the Colcon build again. So Colcon build packages, select drone project. Okay, and then source install setup.bash. Okay, and now I will run the publisher again. So it is sending out the information. It was already working. The problem was with subscriber. So I will run subscriber again. So cd ROS2 workspace, and now I will run the subscriber. So there is a mistake once again. Drone telemetry subscriber. Now the node code that we wrote, the mistake seems to be over there. So let's open the file. We'll simply go directly to this file, nano drone project subscriber. So what we need to do is that, okay, same mistake once again. This is actually a very crazy mistake. This should be inside this initialization. You know, the concept and coding, everything is okay. The mistakes that we are making is just typing mistakes. Okay, so I think this was the mistake. This should be inside the bracket. So Control O, enter, Control X. I will go to the first window, stop publisher. Control C is used to stop that. Colcon build, yes, drone project. Source install setup.bash. Whenever you change anything in the package, you have to do this. Okay, remember that. And then run publisher. Publisher is working fine. The problem is with our subscriber. So ROS2 space, and now I will run the subscriber. So velocity is not defined. The problem is with the velocity. Okay, you can see here message backslash velocity. It is already telling me the mistake. Okay, so I will go to this folder, open this file, and you can clearly see over here message backslash. The good thing, once again, about ROS2 is that it tells you the mistakes directly. So Control O, enter, Control X. Once again, go back to the same window, stop this. Okay, and I will go to main folder, Volcon build, source install setup, then run the publisher. Okay, and then I'm telling this to go to the main folder and run subscriber. So congratulations. So the good thing about this live programming or step-by-step programming, coding, whatever you name it, is that we have also learned how to debug our code. So I told you everything step by step, and we did programming and coding for publisher, subscriber. Before that, we created custom message. And now you see, instead of creating multiple publishers, we actually used the only custom message that we created directly and created one publisher. And we see that the data is sent out by, or you can say that publisher is talking and it is sending information. Altitude of drone 44 meter, speed is this one, and battery is 95. And subscriber is listening to that. So received drone data, if you remember, I added this. You can write anything over here. So it is receiving the information of altitude, velocity, and battery. You may have noticed that it does not start from 0. The reason is publisher is already talking. So when I was writing this command ROS2 run drone project and whatever, it took some time. So as soon as I pressed enter, it started from that moment onwards. So subscriber actually listens in real time to the information sent by the publisher. So I hope this video helps you. I'm also a learner. I'm not a developer yet, and I have reached this point, and I'm trying to help you with it. I hope it helps. And if you have any question, or if you have any suggestion for me, if I made any mistake or said something incorrectly, please let me know so I can learn from you as well. Once again, thank you for watching this video, and I hope it helps you. Have a nice day.